Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Shane and I'm delighted to be joined by Thurupathan Vijayakumar, who will be talking to you about complete application architecture with serverless. Remember to join in the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC18. Don't forget to check out the Resource Center. This is packed with the latest blogs, ebooks, webinars, and how-to videos. Simply visit sharepointeurope.com/resource-center. After the webinar, we will have a questions and answers session. Type any questions you have for Thurupathan in the question window. Some questions will be selected and answered at the end of the presentation. This webinar will be recorded and will be added to the Resource Center, where you will be notified by email when it is available. And now I'm going to pass you over to our webinar presenter, Thurupathan Vijayakumar. Hello, Thurupathan.
Hi. Hello.
Hey, how are you today? Thurupathan, I can see your screen, so take it away.
Yeah. So, hi everyone. So today I'll walk you through the serverless architecture. Probably this wouldn't be the first of a webinar or a presentation of this nature. Probably you would have definitely heard and seen quite a lot of serverless stuff in the web. But today we'll see a different side or a different dimension of serverless, how this evolved and can it still suitable for a complete application architecture, or is still possible to have a side channel where it can help already existing system. So I am Thurupathan, as introduced. You can refer me as Thuru. I'm working as a technology architect at Tiqri Corporation, and I'm a Microsoft Azure MVP and an author. So let's start. So if you take the normal evolution of the computational model, so we started with the virtualization of computers, then it became the infrastructure as a service, where the cloud providers started offering the services. Then it became platform as a service model, where we could build system on top of the platforms without worrying much about the infrastructure. And that evolution all the way took to the serverless. So in a external point of view, as an example, if you see, it is something like how these telco providers, our telco carriers provide us the billing. So they started with a normal GSM connection, and then they evolved with the model, and the business economy evolved with that, where it's went to the minute-based billing, then all the way to second-based and the usable-based. So in that point of view, on a cloud data center and a data center economic point of view, serverless is an approach or an evolution of how we can utilize computational resources, and how smaller and a granular level of utilization can be captured and valued. So that is the root cause why we talk about serverless now from a business economic point of view. From a development point of view, it offers the flexibility and it abstracts lots of layers, and also it adds a very granular level of pricing, which we will go in detail and see how it is. But out of these three, one of the common questions we face when we are trying to put an application architecture, how do we choose between these three models? And possibly the highest question is between the PaaS and the serverless. And in some ways, the public cloud vendors, particularly like Azure and AWS, they sort of stretch the spectrum of PaaS on both sides, on the infrastructure side and also from the PaaS side. For example, if you take Azure infrastructure, we have VMs and other services, but it's been stretched, and recently we can see app service environments and managed database instances and cloud services are coming, which moreover closer to the infrastructure side PaaS. And then we get the normal PaaS vertical web services, SQL databases, and all the other instant-based pricing services. Then in all the way it stretches to the higher end of evolutionary spectrum, where we call the complete serverless idea, where logic apps, Azure functions, or the pure serverless-based pricing, and also the ephemeral computational model behind it. So the choice is a little tricky when it comes to a real world problem. What is the specific choice? And most of the times on a complex solution, we end up utilizing almost whatever the possible pieces from these three verticals. And also sometimes it's not only the development and the technical constraints, sometimes the constraints of lock-ins, constraints of compliance of data, how easily we can move resources in and out. All those kind of business concerns also plays the role where we position our solution. So in a serverless point of view, what makes it special, or what makes it, what are the characteristics that makes it special for a technical decision maker? So putting the economic side a little bit on the shelf, if we talk the technical characteristics, first is the development and deployment cost. It's not the finance cost here, the cost of setting up an infrastructure, cost of setting up a server, orchestrating containers, those kind of costs are eliminated when it comes to serverless. And it can coexist well with the other system, because fundamentally it relates with the point 4 in the slide, because it fundamentally works with the event-driven model. So it can easily coexist with other system with a loose coupled way. And serverless, this is one of my favorite points, is when it comes to particularly the functions or the fast model of serverless, it naturally tends or enforces the developers to think in the problem in smaller units, because you tend to deploy, tend to develop, tend to orchestrate problems in smaller units. So it sort of naturally helps the decomposition of your problem rather than thinking it as huge classes or patterns of code. And the last point, it embraces third-party services, where it's normally known as backend as a service, where serverless is taking one step ahead of the development through low-code and very sophisticated development, design-based development platforms, where the workflow orchestrations are done. So Azure has logic apps, which is the derived version of it's like Microsoft Flow for more power users, and the Logic app has still a low-code platform which has a GUI-based design, and if anything needs, you can go for a logical view and edit it. So these are the fundamental characteristics which makes a technical decision maker to be wowed at a serverless point of view. So how we have been seeing the serverless so far? So mostly there are stories, there are case studies, and there are enough video sessions in the web where the entire applications have been built on the serverless model. Because even when it comes to Azure, the umbrella term serverless covers wide array of services, including Azure functions, logic apps, which are primarily the core serverless serverless service points, but other areas like API management and CEP technologies like Azure Stream Analytics. So they are also covered under the serverless umbrella. So very often we have been using these services directly or as a whole solution or as a part of a bigger solution. But in a normal developer point of view, serverless has been used mostly as a serverless aside pattern. So if you take a application or a monolithic or your application that already in cloud, maybe in a lift and shift mode, or it's already there in a PaaS, if you want to introduce something new, if you want to introduce something valuable to that monolithic code base or a big piece of your application, it's very easy to bring that from serverless. One of the examples and real world examples for a report tool, a tool which gathers data from lots of data points and say that it just finally produces some PDF reports which may be consumed manually by someone and taken into another step to another system. So how we can bring the new smartness under the digitalization process, how we can bring the new smartness to this application in the most easiest ways. Maybe we can plug out the events from that system. Maybe you can add few number of lines in the ORM layer of that existing code base and plug out the events and maybe pump into a messaging platform like a service bus or event hub, and then let your serverless take that and you define your workflow there. Maybe you read the PDF and do some OCR and detect some texts and read back to the database. So if you are with the normal methodology, you could have to modify these systems, maybe search for an assembly or a NuGet package which works with your existing application. But in a serverless, it works very well aside your application. So your application is extended and you bring the smartness to your application from that point of view. So here I'll show you some code. So for example, I have this workflow defined. So I already created these logic caps. So say that you have an invoicing system which has lots of people sending you the invoices in a PDF format. So then you manually evaluate them looking at the amount and do the claim process. So how we can bring innovation or the smartness of the new technologies to that existing system without modifying much of the existing application. So that's the biggest challenge. So we can plug an FTTP listener there, and you can just plug a PDF reader. So when you see now what I'm using is all third-party softwares which are truly being used, and you can put a condition. So what I'm trying to showcase here is you can define the workflow the way it is, and it just runs aside your application based on an event-driven model. There is no restriction or a tight coupling or existing modification for your application. So I will not spend much time on this because this has been a very known model, and you could have easily tried it out with a designer in the application. So going back, so this we would spend much time. So the extensive model of other use of serverless is using a serverless API wrapper. Rather than calling it a full API, it would easily, we can bring an API wrapper into an existing application. So it can target multiple devices. So, or multiple services which are talking from the background. So from a technical point of view, it just works as an API gateway. So how an API gateway can, being a serverless, would help us. There are lots of occasions which can really help us, because API gateway solutions, they are packaged with API management. They come as a bit of a heavy weighted solutions. So if you want to use a serverless based API endpoints, Azure Functions has a new addition called function proxies, which can be used to call any external system, or maybe calling another Azure function, or it could even create a mock endpoint for you to start the development. Because this is another fundamental challenge in the application design or application delivery in the modern context. Actually, when you start a project, there are multiple clients and the developers sort of waiting for your APIs to be ready. There could be a mobile guy waiting for your API to be ready, and there should be web development going in parallel. There should be a desktop application in parallel waiting for your integrations. So creating a complete implementation is not possible in terms of parallelly working together. So the sooner we put the API, so the service contract-based design would help us achieve this. So in order to achieve it in a more lighter way, and even progressively improving it, Azure Functional Proxy helps us in achieving that. So I'll show a bit of a detailed demo on Azure Function Proxies. So when you create your Azure function, I'll just go through this screen, some basics of this screen, just for you to grab the enough information of if you haven't done Azure Functions. So this is my function app. So under the function app, I can have many number of functions. So if I don't have any functions right now here, and I can create proxies, functional proxies, and I can create slots. So these are slots and deployment slots, very similar to the slots we get in app service. So under the proxies, we can create a function proxies which can connect to either to an external service or to another Azure function or even a mock endpoint. So if I'll try to add a function proxy, just simply ask a name, I provide a name, and I just provide a template. And in this case, I'm not providing any backend URL, so later I can provide a backend URL. And I just provided the name and the root template, and I just created. So a proxy will be created, and I can customize it even furthermore, and my URL has been given. So if I hit this URL now, probably nothing will happen because there is no wire up. I'll click on this advanced editor, which will open the function proxy JSON template. So it is a declarative method of creating an API gateway. So that is the very unique and an easy thing for a developer. It has a JSON file called proxies.json. So whatever I have created here, it has come and it is matching the conditions and stuff like that. So I can have any number of proxies. So I can have other proxy maybe for the partners, and it will create another proxy. So that's how it works. And also we can do lots of granular level things under this proxy. It's not only just routing and creation of stuff. Just because this JSON file, you get the benefit of using source control and versioning your functional proxy interface. So I have an already defined proxy here. So I'll try to bring it up. So here you can see the function proxy has 3 proxies I have. One is for products, customers, and partners. And I have the route defined under the mesh condition. So the first proxy has an API, an external service is just calling to an external service with this URL. And the second proxy has a route, and I have specified the HTTP verbs that it should support, and I'm sort of overriding the request. Under the request overrides, I override the parameters, and there is this green squiggly. I think recently they have changed the syntax of that. Yeah, it's pretty cool. Okay, and so I have the overrides, a request override and response override. So the second endpoint, this customer endpoints, it just acts as a mock endpoint because I have just hard coded the response body here. So it will act as the mock endpoint, which will help the developers go and check and how things happen. And the third API, it's sort of function proxies, but the interesting thing is the backend URI is pointed at something like this here, but it says local host. So when I'm just working in the cloud, so what would be my local host? My function app. So whatever the functions inside this particular function app is referred as the local host. So that is the usage of this local host variable here. So I just have this removed, and I just try to run it. So what it's now does is it just deploying my proxy, and my function proxy is deployed as an action. So it's working. So if I try to hit this URL here with this working proxy, I will be technically getting the results what I have hard-coded. So likewise, this is used as an API gateway, a very declarative API gateway. So you can override your request and override your responses to manipulate the request response pipeline of HTTP. So it supports either you can talk to an external service, or you can use it as a mock endpoint, or you can talk to another HTTP trigger or trigger function within the same app. If the function app is an external function app, for example, an external function in another app, so you would be calling it like how we call the external URLs. So you will be putting the full URL of that function. But if it's within the same function app, you can use the local host variable and you can call it. So that's about the serverless. So this been like a really highly used thing, particularly compared to heavily managed API gateway platforms, because it's very declarative. There are other platforms also which are declarative, but this is based on a very simple JSON template, and it helps to bring the consolidation of lots of other services, mocks, and other functions in a very easy and declarative way. So now we enter the main or the key part of the presentation. So the two main features which I explained, like the workflows as a serverless and the API mode of a serverless, it's been like quite used as a part of an existing application, existing complex application. But modeling an enterprise application, a fully complex application which has lots of chaining and functional routines, CQRS pattern, a long-running task, waiting for an external event, and maybe a statefulness, a computational stateful, are really challenging. Because when we move to the cloud world, we advocate and still advocate the statelessness of our application or the tier, where it is very easy for us to scale up. So in order to manage that massive scale out scenarios in the application level, we started using these actor frameworks. So actor frameworks are quite a bit old, but they are recently they are gaining traction because the statelessness of the interfacing layer of modern application should be catered by the application layer, which is stateful. So the actors are sort of gaining popular. So how or in which way the serverless platforms can really help these kind of tough challenges, or can they really help? Is there a way? So that's the core part of it. So in order to explain almost all the scenarios here, so we would be talking about one recent addition, not very recent, a recent addition to the Azure functions that are durable functions. So durable functions are built on top of Azure functions and WebJob SDKs as durable orchestration context. So what is the fundamental theory or the conceptual thing behind the durable functions is they are quite stateful. So whatever the tasks mentioned in this slide, either function chaining or making a status-based HTTP API, they should persist their state. So having these things developed in our normal applications is an overhead that we have to impose or declaratively tell or implement those things in our application. For example, if there is an API endpoint which takes a job task and you submit a job ID back to the client, and in order to check the status of that task, we have to explicitly implement the status endpoint. And when someone comes with the task ID, then we check, and then we just throw the status, or if the status is done, whether we reply with the result or some exception is gone. So all these things should be developed and implemented. Nothing comes for granted, or nothing is actually wired up in that orchestrative context. So can serverless help? Of course, that's the new addition of Azure functions, durable functions are giving us. So this is the high level picture of a durable function, or how it works. So before coming to this slide, I'll explain the code, so which will help the developers to understand the picture here. So I have a durable function which is generated by the Visual Studio, but I have done little modifications here in order to show you a few things. So how I have generated this code is just I created a Azure serverless function, and I simply added a function, and I selected the durable function orchestration. So this template generates a code very much similar to this, but I have added some try-catch blocks and cleaned up some comments just to make the code look cleaner and to show you a few things. So in this file, if you have worked with Azure functions, we can see we have 3 functions. One is called function chaining, which is the name of the function I created, and it has created another function called function chaining hello, and a third function, function chaining HTTP start. So when this durable function is going to be triggered, this is the trigger function that is going to get triggered from an external client. A client or someone is going to call this function using the HTTP trigger. So when this function is triggered, it has a durable orchestration client context, so which is named as a starter parameter. In this starter, we actually create a durable orchestration context, and we get an instance ID, and then we immediately return it with that ID. So we are throwing a return result with that ID. We are not doing anything much here. So how it is started, so what happening behind the scenes when someone receives this request, and how things are started is it's being called by this orchestrator. So the client sort of invokes the orchestrator. Under the orchestrator, we have a little bit code. It's very simple. We are calling the orchestration context, and out of that context, it calls our third function, which is function chaining hello 3 times, and it's awaiting for each time it's awaiting, and it's just adding the output to a string list and returning that list. So things are quite smooth, but what is happening? So the question is, of course, we could do it without a durable function. What's special going on here? The special is how this thing is orchestrated, and what are the other challenges we can solve by this. So first I'll run this code, and I'll show you what is the natural benefit of HTTP status API we get, because there is no modification from the Visual Studio code. It's quite natural, and I just run you and show what happens. So I'm just simply debugging it in the Visual Studio. It just orchestrates the function, and it just gives me this URL. So I copy the URL and I just try to execute. So we get a result. So it says it has a result. It gives a result with an ID, which is the instance ID of this orchestration context. And it gets a query URI where I can click or use this URL to get the status of this request. And it has an event post URL, which I can directly trigger the event from the task hub, and the terminate URL. So if I can get a post message to this URL to terminate the ongoing task. So I haven't actually explicitly coded for these URLs. They are automatically available based on a webhook pattern. That is the benefit coming from the durable functions. So if I just click this and get the results, so I get the results like this. So this, and it says runtime status is complete, and it's been delivering the results to you. So the explicit implementation of such an API is not mentioned here. I think the last time it ran this project, but I'll show you the same project here. But the results is different, but what happens behind the scenes is same. So explicitly, I haven't implemented anything to expose those URLs. The only thing I'm exposing is the instance ID here. This is the instance ID returned in that main HTTP URL I get. It's simply starting the context, and the context is returning an instance ID for me, and I'm just returning that instance using create check status response. So this method is producing the JSON object we wanted, or the JSON object that you see here. That's part of the durable functions SDK. All right, so now let's do a change and see. So these are three functions. So this is our client functions, which gets the HTTP or the external events. And this function calls the orchestrator. So he acts as the brain of this orchestration or this durable function context. And the last function is the activity function, which is doing the real work of what we need. So that's what shows here. So we need an external function, or it could be even a client, and we have an orchestrator and we have an activity function. So activity function is the very low level thread kind of a thing in the durable function context. So how this works? So when we have three functions, so when we deploy this now, Azure will create three functions for us. So how it works? So what is the difference? For example, you can simply ask, what is the difference of calling this function using this call activity async, rather than I can simply call the say hello method 3 times? It's a pure C# call. So what is the difference between calling like this and not calling directly? Because when it comes to a durable function, the orchestration works something called task hub, where durable function creates tasks hub in the storage account and persists. So this helps us achieve the advanced scenarios what explained earlier. So what you see here is a simple example of function chaining and a natural HTTP call. Say, for example, for your activity to run as a separate function where you can achieve more benefits of scale out of the serverless infrastructure, if durable functions are not there, you have to call that specific HTTP function through another event trigger. So either you can call it via an HTTP trigger if the HTTP function exposes, or you receive a message from the external, say you receive a message from your web interface and one of your HTTP function receives it, and you either call to the other function with another HTTP call, or you just put an event in a service bus and that function triggers out. So the chaining of the functions is very easily orchestrated by this call activity async. So that is the fundamental difference between why this orchestration happens through the call activity and not directly calling another function. So if I technically comment this, so now our activity function is no longer there, but we're trying to call that by call activity async. So it is no more a function if it's just a C# method. So I can simply call it like this, but this doesn't create a fan out scenario. That means this entire function is executed within a one serverless function context. So you don't get the benefit of fanning out and fanning in. So here, since we are using the await keyword here, the fanning out is not properly executed. But if you go to another sample like this, where I'm calling my calling activity functions in a loop for 5 times, and I'm just waiting when all are finished, and I'm again reducing it with all the results. So I'm waiting it here. So this would gives you the best benefit of fanning out your work, doing you receives an event, fan out your work, then again fan in and get your results. So that's the benefit of durable functions and the orchestration context. And also it helps you by giving you the automatic response status checking API endpoints, which is available for that context for this particular instance ID. So as long as your client receives this instance, you can actually check the status of your job. The client can call to that instance ID and check the status of your job. So that would help us lots of orchestration code outside our business logic. So everything is handled by this method simply here. So if I just call here and I just execute it here. So you have instance ID. So this is one instance, so I'm just calling it again. And I have a different instance ID here. So this is a different ID, and this is a different ID. So each time the orchestration context is executed, it is given instance ID, because we haven't passing an instance IDs here. We are asking the method to create an instance ID for us. So every time we invoke our durable orchestration context gives us a new ID, so that we can use it for checking the status of our work. The other stuff is it's introducing the long-running tasks. So this orchestration context is quite powerful. So if you just simply put dot, and you can see what are the other options we have. We can simply call an activity function, which is what we are doing in this case, or you can create another orchestrator. So maybe I can have another orchestrator, and we can call that function to work for us. So we have an orchestration 1. So, and we can call that orchestrator to fan out scenario. So if we have a high throughput parallel kind of a thing, so we can have sub orchestrators, and you can call that guy for here, and you can just pass the input of the string, say func1, and I don't want to pass any input, maybe not at this time, and I just name him function name func1, and I just wait for his result. So then he does the activity here. So it's sub orchestrators are quite easily possible. So why we need a sub orchestrator? So if we have one orchestrator who can handle more than one activity, so what is the scenario of why we need another sub orchestrator? Because if your business context is different, say for example in one single request that you want to do some activities, and also you want another set of activities which are waiting for an external result. So in this kind of an example, you don't need a sub orchestrator, but think your sub orchestrator has a code like maybe continue as new, where you want to continue a new orchestration logic, or particularly that you have waiting for an external event to happen, and you can input event ID, something like that. and you can just get the things done. So in that way, so by creating sub orchestrators, you can create a tree of your work, a tree structure of your work. Anyhow, at the leaf level of the trees, you will be having activity functions, but orchestrators calling orchestrators and calling orchestrators, and end of the day, the real job is done by the activity functions. So consolidating different outputs from different orchestrators, we can dynamically provision. So it's the possibility is sort of endless. You can create chaining of orchestrators, and we have a workflow of things we can do. So that would help us in creating a complex workflows in code. So the early example where I very roughly showed using the logic apps is I used a designer, portal designer, and I created a workflow. But if you are creating a workflow, say for example, if you have a business case where you get an input and you have to do certain activities, and on the other side you have to wait for someone to approve it, and the approval comes as an external workflow, and if that approval doesn't happen for 3 days, then you have to go and create or do something else. So those kind of things can be orchestrated by sub orchestrators. The last thing is actually the singleton-like pattern, or this actor-like. So actor concept is quite different from what I'm trying to show here, but you can call a parameter, or we can create and instruct the orchestrator to have only one single instance. Say, for example, if our orchestration client is running only one instance and it is maintaining its own state, it's somewhat very similar to sound like an actor, but of course it doesn't provide all the necessary building blocks of an actor system, but at least that one single running orchestration context would sound like an actor. Say, it's quite easy. So in this case, we are here, we are not passing. So in an orchestration client context, we are starting the client, and I'm providing what orchestrator client to call. So this is by the name. This guy is knowing I have to call this guy, and this is a parameter we are passing null. So if I just delete this and say the second construct, as you can see, so I'm just passing the function name, say func1, that's my orchestrator function, and I'm passing a string instance ID. So it could be anything from a client input, or it could be something that you define as your actor ID. Say, for example, you're creating a multiplayer scenario, so your game session would be an actor. So that's time, say game session ID, and any input object. So at this point, it's not. So I have provided this instance so that I know the instance ID. So what is returned here is whatever the string I passed. So in order to make sure no one else is executing this, in order to complete the one execution, and then only we have to start the other execution, before starting this, what I can do is get status async, and I can pass again the same, whatever, call it an ID here. So this should be that ID here. So, and status, wait, and if status is now, if it actually technically if it's null, that means that execution is not there, and if it has a value, there is already an execution happening at that ID. So by this, we can sort of create a singleton instance of your orchestrative runtime, and sort of mimic the actor, but inside that singleton instance, how your activity functions are implemented, how your activity functions are coordinating with maybe someone else, might trigger a behavior which is not expected. Sometimes it might create a race condition, but if the wire up is carefully done, and if this is the status that we really wanted to have, we can achieve something called a serverless actor by this implementation. because it is not intended to create an actor-like system, but the benefits or the features it brings us would be immense, because having full-fledged actor systems on a typical system is quite complex. It has lots of quite a number of learning curves just to get the benefits of actor system. We can just implement this, and the developers would feel it's quite easy to continue, because it stops the learning curve of studying the entire system. So that's final thoughts on the durable functions. So that's the real tough challenges what these new durable functions can really solve us. So I actually didn't show the entire working piece, but I will make sure the code and the proper work of this entire structure as a working code will be available in a GitHub URL after the session. The main idea was in the session is to show you the contextual advancement and how and what are the things feasible during the durable functions and the orchestration context. So this is the fundamental wire-up between the three main pieces in a durable function. So in a durable function, you can assume as set of three functions. Of course, they can be developed as one single function also, but set of a composition of these three types of functions creates a durable function context. A client or external trigger which expects to be started and it initiates orchestrator. Sometimes orchestrator itself can be the external trigger, and it has an activity which is like like a very similar to a thread in a normal process, the low-level guy who does the work. So now let's see what are the challenges of using particular durable functions and other serverless things. The high vendor lock-in is the highly risked and highly discussed thing, which sort of demotivates most of the decision makers to not look at the serverless context, because even the examples that I showed you with the durable functions, when you implement such a thing, that you have a very high lock-in with the Azure functions, if not the lock-in with the Azure itself, and it has a very high lock-in with the function frameworks itself. And on a logic apps or a workflow-based apps, we use third-party services in order to bring the development faster, but third-party services are moving targets in terms of the implementations, licensing model compliancy, so you have to have your own regular updates with them in order to keep the things aligned. And third thing, particularly when it comes to durable functions, the compliancy and issues in data, so mainly the intermediary data. For example, if it's a long-running process and you are getting the work or a task ID, where the intermediary data is persisted. If it's a long-running durable function waiting for an external event, where it is stored and how the data compliance is addressed there, whether it is encrypted or is there any compliancy tooling that you need to apply on your event-based approaches. So those are big challenges we have to think when we are addressing as a whole solution. And final consideration, lower cost is not a promise, because that's commonly one of the key things that which I see is when we talk about the serverless, the main idea behind the serverless is getting promoted as it's lower cost, or it's really supports startup cultures and everything. Of course, most of the public cloud vendors provide a higher cap of free initial usage, but that doesn't mean it's lower cost in all the implementation, and particularly when it comes to enterprise level workloads, it's not a real promise the cost is lower. And serverless is not microservices. Serverless thinking and the event-driven model and the granularity of and the decomposition of the problem would definitely help to think in a microservices way, but fundamentally those two are different concepts. And the logic and the workflow tools or the workflow designers what we use is sometimes it's been taken as a low-code development platform. It is not a low-code development platform when it comes to serverless. Maybe how the serverless is presented there, maybe the drag and drop interfaces and stuff looks like sort of a tool, but fundamentally the running cost and the implementation and the ephemeral computation are quite different from it being seen as a tool. So these three are quite of highly available myths, I would say, in the industry. So before going to the end, I would like to show when it comes to Azure functions, we can create a function app in two modes. One is the consumption-based mode and the app service mode. App service is using the serverless techniques and the technology under the PaaS model, and the consumption basis, it brings the economical or the billing side also as a serverless. So I have created these two apps here. So one is the Bronze Fang app. So it's created as a consumption model application. The app service function is created as a app service function. So you can just go to the properties and see what is the underlying the pricing tier of that. Or the easiest or the most technical feature is actually you can go to the resource JSON. So it can be immediately identified. So if you want to automate and stuff, so how you can create a resource-based function. And just say here service plan, and if you go to the resource, if you go to that, yep. And here you can see what is the computation mode. It's the computation mode is a dedicated computation, so you get a dedicated VM. So in terms of timeouts and everything, you get a bit of a higher benefit here, but whether you use it or not, you are charged. But if I go to the other app service plan, which is the Bronze Fang, which is under here, and if I go to the resource, so you can see the computation mode as dynamic. So the dynamic is the per consumption pricing model that's been used here. So you can say the computation mode is dynamic, and here the computation mode is dedicated. So these parameters that you can just use to automate if you are provisioning resources in terms of using an ARM template or stuff like that. So that's the end of the presentation. I hope you enjoyed, and I'm open for some questions.
Thank you for a great presentation. That was super, Thurupathan. And now we will start the questions and answers part. So should you wish to ask a question, type it into the questions window. The first question in here, Thurupathan, is what is the difference between the function proxy and API management?
Yeah, it's a function proxies. It just have a very declarative, lightweight API gateway, whereas API management, the Azure API management is a full-fledged API management tool. So it has API gateway and other additional stuff like API orchestration, the developer portal. So the API management suite comes with a very comprehensive API tool like monitoring, telemetry, so everything is packaged. And in terms of pricing, it's a PaaS model. It's priced and it's highly expensive. But function proxy is a very lightweight, declarative API gateway.
Great. In the durable functions, where sorry, one sec. In the durable functions, where the data is persisted.
When you create a function app, so you typically provision a storage account, Azure storage account. So the data is persisted, the intermediate data and the logs is persisted in the Azure storage account, but you provision them.
Great. Thurupathan, thank you so much for your time today. Very much appreciated. I know it's quite late in the evening in Sri Lanka at the moment, so much appreciated with helping with this webinar today.
Sure, no worries.
Thank you, Thurupathan. Okay, everybody. So that is all for today. See sharepointeurope.com/register- for webinars for further details on all upcoming webinars. Also, you can check out our resource center at sharepointeurope.com/resource-center for all previous webinars. Thank you to Thurupathan today for a fantastic webinar. Thank you all for attending. Thank you and goodbye.